All right, so now let's try and create a proc file entry in the sense that we are going to add an entry into the proc directory, and that entry, let's say, is the pajama underscore driver, right? So we want to add this virtual file, right? Virtual file. And again, this is a virtual file. It doesn't exist on the disk. It doesn't occupy any space. It's just an entry, a virtual file. Now, what we want to do is first add this entry, and then the second is associate, the read, associate, or rather, let me do this, associate the LDD driver uh, with the operations, right? The proc operations, proc ops, right? And once we associate the proc ops, like through the proc ops, the LDD driver, then what will happen is the read and the write on this will be caught by the LDD driver, and it will respond for it. So we're going to add those functions in. So as part of this video, we'll just focus on creating this entry. And as part of like the future videos, we'll go into implementing the read operation, so to speak. All right. So what do we have on the screen here? So this should look familiar. These are like the header files that we have been including. I kind of modified this a little bit to add, some information here, and this should also be familiar. I deleted the code within this and also within this, and these are the module init and module exit macros. Now we are supposed to implement something here and something here. So what I'm going to do now is let's kind of, bring up the header file, the proc underscore fs header file, and let's look at the proc create. Um, let's look at the proc create function. So this is the function that will be of use to us. So let's then go ahead and copy this and bring it back here. So let me just go ahead and paste it here. What we want to do is assess, oh, well, how did this open? Okay. What we want to do is essentially assess what all parameters this takes in, and so what all we should be, populating. Right. Okay. So name seems like, well, it looks like a string. So we'll just provide name here. And then this is umod underscore t, some mode, umod underscore t. And so we'll need to figure what that is. And then there is this struct proc directory entry parent. Looks like this will be parent of, the proc entry we add here. And then there is some const struct pointer to proc ops. All right. So the operations, as we saw yesterday, or in the, well, I was recording the video yesterday, but in the previous video, what we saw was that the proc ops is this structure right here, right? And so we are supposed to kind of implement the entries within this. So that is like another requirement. So what are we going to do now is we are going to, just because we are trying out things, we are going to set this to 0, right? Just because, okay, I should also mention that if we go back here, the way you can, kind of uh, process and figure out. So what we are going to do is it on the right side here, GitHub is telling me that, hey, types.h has this u mode underscore t. And what is u mode underscore t? It is nothing but a type def of unsigned short. So because it's a short, what I'm going to do is set it to 0. I don't know what the valid value is. I'll just set it to 0 because I can, right? Now here there is const char star name. So I'm going to, name this as pajama underscore driver. This is where the name goes. And what this name is indicating is in the uh, proc directory, what is the entry that we want to create? And we want to create by the name pajama underscore driver. So that string I'm providing here, right? So the mode is set to 0, whatever that means. We'll see whether or not it works. I'm not so sure on what the parent directory has to be. So I'm going to again set that to null, and I'm going to set it to null just because it's a pointer. And right now I don't even have the proc ops. So I'm going to set it to null as well, right? And so looks like it's going to return something like this, the directory entry. So I'm going to have a static variable for that, and I'll call it what do we call it? Let's call it I don't know, proc entry, right? uh, Entry, right? So let's just call it proc entry. This is a static because I just want this variable to be accessed by the entries or functions within this file only, and that is also the reason why we have static here. All right, perfect. So all of this is set. I just have to get rid of all of this, and let's just then go ahead and equate this with this, and then I'm cutting that. And what I want to do is I want to create this entry as part of my initialization function, because remember, when the kernel is loading the module, it will give a call to pajama module and underscore init, and that is where the content within this function will get executed. Now, to be able to detect that we are actually within this driver or this function, what I'm going to do is just write entry slash n, and then at this point I'm going to write exit. So this way we'll know that we entered the function and we exited the function, right? Okay, perfect. And let me also kind of go ahead and align this with the function. Well, let me just align the function parameters. Perfect. So now what we want to do is we have created this proc entry, and actually just because I'm copy pasting my from my notes elsewhere, I'm going to rename this to custom proc node, just so that as the code develops, I can continue to copy paste from the file that I have on the side. All right, perfect. So what is going to happen here is, if this succeeds, it's going to provide a pointer to that node here, and that is used later. And later in what sense? So as we are inserting, doing like a ins mod on ldd.ko, uh, this init function gets called. That should be like absolutely clear by now. And so what we are doing is we are creating this node, we are creating this entry here, right? Pajama underscore driver. And what we expect now is, as we unload our module, as we do rm mod on our module, right, we would want that this entry go away, right? So in order for the entry to go away, what we need is another function that we can call from the exit module, and that has to kind of do with think it's called the remove parent directory. We can use, oh, just a moment, right, we can use this proc remove function, right? We can just go ahead and copy this, and let me just go ahead and paste it here. So proc remove entry, and note that this is like returning void, so we need not catch that return value. It is not going to return anything. Sorry, this is the one. So it's not going to return anything, so we need not catch anything, right? So that's why we have this. And then it says it takes a pointer to proc directory entry, and we have the custom proc here that we got, so to speak, the pointer to the node, right? So I'm just going to or the pointer to the proc entry, so I'm just going to go and pass this right here, right? And then much like this, what I'm going to do is print that we are in the module exit, and let me go ahead and also do this. ENTRY, right? Okay. So this is the important action here, right? Perfect. Now, what is worth noting is we as part of initialization, we are going to introduce a node into the proc entry, and as part of the exit, we are going to remove that proc entry. So as part of this video, we're wanting to just see if we can add this proc entry or not, right? So what I'm going to then do is go to terminal, create a new terminal and put it on the side here. And then I'm first going to list entries in the proc. And what we should note is the 𝘁𝗵𝗶𝗀 driver, right? The 𝘁𝗵𝗶 driver, that entry is not seen here, right? It doesn't exist, which is perfect. And now what we are going to also do is we are going to do ensure that our log buffer is clear. So log buffer is clear, there's nothing there. And now I'll go ahead and do make, and something happened. So it's complaining that it cannot find proc remove and it cannot find proc create, which is understandable because I did not tell our compiler which header files to look into. So the header file to look into is this Linux proc_fs. So I go back here and essentially add that entry. So we then say, okay, Linux proc_fs, and then I'll go ahead and kind of make clean, and let me just refresh. Yes, perfect. And then I'll go ahead and do a make. Now let's see what happens. So it just went through fine. The compilation was clean. We have our ld.ko available here. Now let's go ahead and do an ins mod on this ko. So ins mod, okay, sorry, this has to be sudo ins mod, and then we say ldd.ko, and it says segmentation fault. So something went wrong here. Clearly something is off, right? Something went wrong here, right? And now what I'm going to do is check whether or not the module was inserted. So I'm going to use um, essentially ls mod, and let's scroll up here. Oh, looks like ls mod is inserted. You know what's funny? It's also used by someone, and we don't know who is using it right now. Okay, so that's the looks like a problem. So what we're going to do is now investigate into what happened here, and so we'll do sudo dmessage, right? We are going to execute this command right here, and oh god, there is so much printed here. Now the prints might vary for you in terms of specifically these prints. These are specific to the CPU architecture that is being used, but something's interesting here. So it has printed pajama module underscore init entry. You can ignore this print. This has to come from this has to do with the fact that the kernel buffer was not completely flushed, and this was like a residual entry from a previous run, so ignore that. This seems or looks familiar, right? Pajama module underscore init underscore or colon entry. Perfect. So we are now going to look for whether or not this function exited, and doesn't look like, right? We do not see this printed, which means something went wrong here and something bad happened, right? And we also see proc create something, which is same as this function, right? And then something, 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 bad things are happening. And uh, what might be happening here, again, this is just my hunch, which is, and again, this is like a biased hunch, which is maybe one of the values here is incorrect. Maybe something was expected, right? And I know in hindsight what is expected here. And let me go ahead and see if I can provide you with some information as to how one can figure that out. Mm, let's see if I can reason about it. Uh, hmm, Something happened here. Code audit. Operation open, something class file, something something, denied mask R. So somewhere again, given my prior experience with this, it tells me that it should also, we should have also given it the file operations here, or the proc operations, which were listed somewhere here. Just a moment. Yes, proc create. So we should have given the proc ops. So what I'm going to do is copy this, right, and paste it here. So we're going to create that variable, and let me also name that variable in a friendly way. So let's have this, and I'm not going to define a pointer to it. I'm going to define this variable itself, but I'll keep it empty, right? So this is a struct, this is a struct, and what we're going to do is take this struct, and because there was a pointer required here, we are going to provide the address, right? So note carefully what's going on here. We have provided the address of a variable that is of type proc underscore ops. And my hunch was that the create proc here went into, or ran into trouble, or ran into issues because we had not given this, right? Of course, I'm unable to pinpoint as to, what went wrong here. There has to be some line which says, something was missing, but that's not, there. So we suspected that something will be wrong. I'm pretty sure that a proc entry can be within the parent, so this null should not be a problem. File mode can be 0, so this should not be a problem. So this is the only one that is in my head, how I, um, again, based on my previous experience, landed on this. I was looking for something here that would suggest, but there is no hint of that. Okay, so hopefully it's clear as to why we are passing the address here. The address is because this entry here takes in an address, right? Takes in an address here, and that address we can get by having a variable here and passing address of that variable. Okay, perfect. And so now we are going to do something, which is recompile all of this. All right, so let me pull this right here. Let me do make clean. Let me do make. Now the thing is, ls-mod was showing that our, you know, driver is already in use. And now we are going to attempt to remove it, because the previous instance of the driver that we injected, we first have to remove that. So we are going to do sudo rmmod ldd. And there is a problem, right? So looks like we cannot remove it because it's in use. And who is using it? The kernel's using it. It's in like a half baked, or it's like a half loaded state, so to speak. And now what we are going to do is also check whether the proc entry had got created. And okay, I'll just type no, and type pajama. Nothing comes up. I'll just do this. Nope, nothing related to pajama comes here. So obviously the proc entry didn't get created. The driver is half loaded and something went wrong. We saw errors. Again, we saw this, right? All bad things. Now what do we do? And the answer right now is we will need to reboot or restart our machine, because the kernel, we have kind of screwed it up. It's in a bad state. And this is exactly why we had kind of, installed multipass and decided to do all our experiments within multipass. Just because if a situation of this nature happens where we screw up the kernel, we should be able to kind of, revive the system. Okay, so then I'm going to do multipass stop primary. That's how we stop the primary machine. And if you see, the moment I did that, it's attempting to reconnect, right? Because the connection from VS Code is lost. And now we'll do multipass start primary, right? To kind of restart that system, or boot it up, boot the instance, the virtual machine. So let's see, let's wait for it, starting primary. Let's just give it a minute maybe. All right, done. So it is running, and I can confirm that by doing multipass list. Primary is running here. This is attempting a reconnection. I'm going to again click on this, close this remote connection, because it'll take a time to reconnect and I don't want it to take that much time. So I disconnected it, went to the remote explorers and reconnected back. It asks me for my password. I'm going to give it the password P, and now we are back here. Perfect. So let's first do ls mod. And now if you notice, our module is not there, and which makes sense. Our module was loadable kernel module, and after a fresh boot, the module is supposed to be manually loaded, and we did not load it. So that's that. Perfect. All right. I'm also going to do sudo dmessage. Oh, there are a lot of messages here, because the kernel was booting up, or the system was booting up. So I'm going to go ahead and now clean those. Perfect. So now when I run dmessage again, there is nothing. So clean buffer. Perfect. I'm going to do make clean. Everything's gone. Let's do make again. Everything is compiled. Now from the previous run, the only change we have made is this, and there are no entries within this structure, right? We're just providing it with address of a variable, a struct variable that has nothing, right? Okay, so if we are done with this, we are going to also do ls proc, just to make sure there is no pajama driver here. And now I'll go ahead and do sudo ins mod ldd.ko. This time around, everything went fine, or so we think. So sudo dmessage, and looks like, yeah, things are fine. We do see these two prints here, which is entry and exit, which is entry and exit. So this is good. This is great. And now let's go ahead and do well, mod info first. Oh, sorry, ls mod, not mod info, ls mod. And we see ldd. Ldd is not used by anyone, which is a good news. All right. And then we do ls proc. And now somewhere here, there should be pajama driver, which I'm not able to find, but I just found it out and it is available right here. Perfect. So a file entry got created within pajama, like within proc and pajama underscore driver. So again, note that this entry was necessary. This is the syntax in terms of how you'll go about creating that node. And so let's go ahead and run one more experiment, or two more actually. Let's try and read this. So cat slash proc, pajama driver, and it says, okay, there is an input output error, which kind of makes sense, because even though we have provided the structure was supposed to have the function that implements what the driver should do once this proc entry is read, and we have not implemented it. So given that there is nothing within this structure, the kernel understands that we haven't implemented that function, and so it doesn't even call and prints this error instead. All right, so can we then echo something into it? So let's say echo slash proc pajama driver. No, we cannot even echo into it. Permission denied, it says. And now let's go ahead and try and see if sudo works. No, that doesn't work either. And all of this should point to, or kind of and reinforce that the fact that we are not able to do a read and a write, the fact that the operation doesn't complete in any sense, is because we do not have the proc operations implemented. And what were the proc operations? So if we were to go back, the proc operations were the functions of these nature. So that is not implemented, right? That is important. Now I'll go ahead and do sudo rmmod ldd, right? And then do lsmod. This time around, our module is not available. Let's again do sudo dmessage, and looks like the exit was also called correctly. And then let's do ls in the proc, and our driver entry, the proc entry, is also taken out. So we have then successfully added the entry in the proc system, file system, or the directory, and we have successfully removed it. And with this, which this is like an important milestone, because the next thing we do now is implement the read function. And once we have done that, we'll kind of check whether or not reading that proc file system works. All right. A question that I'm wanting to explore now before we kind of conclude this lesson is, when we provided null here, things went wrong, and our driver loading should have failed very gracefully, and it did not fail, right? And the question is, a driver writer should assume that the initialization of driver can fail at any point. And if it fails at any point, we're supposed to kind of undo, right? Undo things and fail gracefully, right? Just so that the kernel is not left in a bad state. So the thing that we should have done is we should have guarded this function execution and put this here. So if this is null, and the other way to kind of check that, one way is to just invert it, the other way is to do so if this was null, we should have actually returned some sort of a negative number. And again, there are like error codes to be returned instead of -1. That's like the standard practice. But let's just do quick and dirty experiment here. And I don't know if this works, but we'll see. And if this fails, I think it will be a good exercise for you to figure out how this failure should have been handled. All right. So, okay, let's see. We are saying error here. Perfect. And then we return back. Um, let's go ahead and do make clean here. Then do make everything compiles fine. We then do sudo, ins-mod ldd, and something nice happened here, right? It says ins-mod error could not load the module ldd, no such file. Okay, that is because I did not use ko, and segmentation fault happened. So something really went wrong, right? And I think I have learned something. So let's do sudo dmessage. All right, same crash, right? So this is bad. So this is really, really bad. Then we do ls mod, and let's see. So same symptom, right? Our LDD module has put the kernel in bad state. And did the proc entry get created? Uh, doesn't look like. I'm not able to find it. Can you find it? Okay, nope, I do not see it. So what really happened there then is the kernel crashed while executing the create proc function, or proc create function, and it did not return back at all, right? So somewhere within the proc create, there should have been a check for whether or not the proc ops is available as a parameter. And if it was not available, it should have returned back a null here, and then we could have checked it here. But we could not do anything because create proc underscore create itself crashed. Cool. So now what I'll need to do is, again, reboot my uh, primary machine, and then kind of go ahead and implement or proceed with implementing the read function. So what I'm going to do is restore this back to the working state, which is this, right? This was working for us. And now what we'll do is we'll go ahead and implement the proc read function.